Good evening, everyone. Good evening, ladies and gentlemen. First of all, I'd like to welcome everyone who has joined us today. On behalf of entire KIPS team, I'd like to welcome each and every one of you. I hope you attended the previous session which we conducted in the last week on the basics of artificial intelligence. And in today's session, we will be covering a few more concepts, some deeper concepts, some technical aspects of artificial intelligence. So sit back and relax. We'll be starting very soon. Good evening, ladies and gentlemen. On behalf of KIPS, I would like to welcome each and every one of you for joining us today on this special occasion of the webinar, The Power of Artificial Intelligence, the Unlocking the Next Level. I hope many of you have already attended. I think every one of you have already attended the previous session which we conducted in the last week. So give us 2 minutes, we'll be starting very quick. Hello? Good evening, everyone. So again, I would like to welcome everyone who has joined us today, and I hope you all have already taken part in the previous session which we conducted in the last week on the basics of artificial intelligence. And in today's session, we will be diving into some deeper concepts and more technical aspects of artificial intelligence. And we will also try to connect it to the real world example, and also we will discuss about various applications and a lot of modern technologies and approaches which are being used in artificial intelligence that we use at the present time, right? So without further delay, let us start the session. So sit back and relax, and we will be posting this video post live session, and we had a great response in the previous video that we previous session that we conducted in the last week on 11th of April, and we hope that this video also reaches to the maximum number of people. And I suggest you just once the live session is over, you can actually go to the KIPS page and you can watch this video again and again if you have any kind of query or you miss out on any kind of information during the live session, right? So let's start. And you can also comment your questions and queries once the video is posted in the timeline of KIPS Facebook page, right? So in the previous session we discussed various things related to artificial intelligence, the basic concepts, and also we discussed a lot about generative artificial intelligence, right? So when you say AI, artificial intelligence is actually, it's a very you can say it's a very huge domain. It's a very huge domain, and it's not just a computer subject, and it's not just the computer topics which just about artificial intelligence tools or maybe artificial intelligence platforms that we all are using, right? This is much beyond that. So in the previous session we discussed many things related to artificial intelligence history, its evolution, and also a few things related to machine learning model. Okay, so it's kind of a continuation of the previous session which we have done. Now we will start today's session with a very important topic which is called the life cycle of artificial intelligence, or you can say the complete project cycle of AI. So see, it's a technology which has a lot of advantages. It's a technology which is designed to cater to a lot of problems that we are facing, right? It's a tool which can be a solution to millions of problems that this entire humanity is facing. So to start with, we will initially talk about the project cycle of artificial intelligence. Okay, so what is basically project cycle? So it's nothing but the steps that we follow to design a product which is related to artificial intelligence. Okay, so it's not only about artificial intelligence. When we go for designing any kind of product, we need to follow a certain strategy, certain steps. Okay, so that is actually followed in almost every product design. Okay, even if you talk about design thinking, we follow certain steps, right? All of you must be knowing about design thinking. So here we'll be discussing the project cycle of artificial intelligence. So every AI model that is designed, every model which is developed are actually having some kind of application, some real world application, or maybe some days there's a need of that artificial intelligence platform. Okay, so that basically starts with something called a problem definition. So when we design any kind of product, the product has to be a solution to some problem. Okay, and it has to be a real world problem which the product is solving. So AI also falls into the project cycle where we follow certain stages, certain steps to design a product. Then we do certain steps to evaluate the product. Then we do certain steps to improvise or update the product. All right, so the first thing is basically the problem definition. So in this case we need to find out a problem for which we are designing an AI product, right? So why this is important? So this is these topics, many of the topics that we'll be discussing today are actually an integral part of the curriculum, especially if you talk about the grade 9, 10, 11, 12 artificial intelligence curriculum. Many of the topics will be from these domains, right? So those who are associated with these grades, these classes will be very much able to connect to this session, right? So initially we need to do a problem definition. So we have to identify a problem, then we need to try to set an objective. Okay, what and how we can do and what we should initiate to solve this problem using artificial intelligence. So now in the previous session only we discussed about data. Like artificial intelligence is all about data, right? So an AI model is designed depending upon the data. So artificial intelligence actually works on data. So without data, the designing of AI model is not possible. So in the previous session, I already discussed about the machine learning model. So a machine learning model basically is something that we design using a lot of data. Now, when we go for designing or maybe putting up data in any kind of AI model, we are supposed to again do lot of different sub steps or you can say processes that we need to carry out in the data collection process. So after you define the problem, after the problem definition, you need to go for data collection. So that means I'll give a very basic example, right? Let's say for example weather prediction, right? I want to develop an artificial intelligence to predict the weather. Okay, what will be the change in the rainfall, what will be the change in the humidity, what will be the temperature that is gradually increasing every single year, and how the complete weather is behaving in a certain locality, a certain area. So that is possible through a lot of data, right? So we have identified a problem, we have defined the problem, then we need to collect the data related to that problem. So that is basically called the data collection. So once the data collection is over, the next thing that we'll be going for is the data preparation. So in the previous session, those who attended the previous session that we conducted in the last week, in the previous session we briefly discussed about the data process. Like data science is also a part of artificial intelligence, which plays a very important role in designing any kind of artificial intelligence model, right? So after the data is collected, then we need to prepare the data, right? So preparing data is nothing but making your data perfect, or it's kind of cleaning the data, you can say, right? So data processing, it's kind of a data processing. So as I have already mentioned in a previous session, that we cannot directly feed any kind of data into any kind of AI model randomly. So we need to follow a certain process to give the data to the AI model. So that is when we achieve a clean and efficiently functioning artificial intelligence model, right? So when we talk about data preparation, we initially go for data cleaning, then we go for data engineering, right? So let's say for example I have collected the humidity and temperature, rainfall information of that certain place where I want to solve that problem using artificial intelligence, because it might be to save people's life, it might be to save people's natural resources, it might be for anything that you want to use it for, right? Because AI can predict something, and with the help of the AI we can actually find out what's going to happen tomorrow. Is it going to be a rainfall tomorrow? Is it going to be a are we expecting a drought, or maybe is it an earthquake, or is it a tsunami, right? So this kind of things can be predicted using artificial intelligence, and it's being done across the world, right? So that data which we collect are actually the data which is there from before. That means, let's say for example I have collected the data of that certain place of last 10 years, how the weather has behaved, how the rainfall has behaved, how humidity and rainfall has varied in last 10 years in this area. That is a kind of data we'll be collecting, and that data we'll be using, right? So we cannot directly provide that data to the machine learning model. We have to do data cleaning. There might be some data which is having some error. There might be some data which is having kind of misvalue or misinformation. Okay, so we have to clear those data. We have to make sure that the data that we provide to the AI model is actually the perfect, and it's going to really make a pattern in the data, right? So that is something that we need to take care of, and that is done through data preparation. If your data preparation is not good, if your data cleaning and data processing and data engineering is not proper, then you will end up teaching something inefficient to the artificial intelligence model, and you will not get the desired output. So that means your expected output will not be very similar to the original output that you get from the artificial intelligence. Okay, so there is something called exploratory data analysis, EDA, the next step. So this is basically finding the data patterns, like deeper patterns, Let's say, for example, I have collected the data of that place for last 10 years, and I have found that in the month of April or May, the humidity starts increasing very rapidly. And at the same time, we face lot of frequent rainfall, right? Correct? Or maybe if I go deeper into that, I find that, whenever there is a, high temperature in daytime, in the evening, there's a high chance of raining. So that means what? You get a rough data, or maybe you can say accumulated data. You get inside the data and you find out a lot of patterns. That's how the artificial intelligence also finds those patterns and try to implement those knowledge for the future prediction, right? So that's what we call EDA, exploratory data analysis. So when the data insights are figured out, then we are able to, achieve a good output from the machine learning model, because we have provided perfect data, we have provided clean data, and that data is teaching something very good to the artificial intelligence model, and it's giving the perfect output the way we desired. As simple as that. Okay, so the next thing that we talk about is the next step is the model development. Okay, so your data is ready, you've collected the data, you've cleaned the data, you've analyzed the data. After that, you are supposed to develop the model. So the data has to be now fed into the machine learning model. Okay, you need to choose some algorithm and you need to train the model, right? So if you all remember, in the last session I spoke about two things, that a machine learning model is basically comprised of two different things. One is the data and the second one is the algorithm. Okay, so algorithm is actually something that it is our complete user specific, or you can say developer specific, or maybe organization specific. Okay, because what we want, or it can also be country specific, or the region that you belong to, the government that you are under. So they're like algorithms might be dependent on many humanly activities or policies, guidelines, a lot of different things, right? But coming to the training the model, that is completely a very common process that every artificial intelligence is designed upon, because all the steps that we follow are very similar to designing all the artificial intelligence platforms. But when it comes to modeling the artificial intelligence model, designing the AI model, then we use a huge amount of training data. So that is also something that we have already discussed in the previous session, right? I told you that almost 80%, 70 to 80% of the data is used for training the AI model, and remaining part of the data is used for testing it, right? So after the model is designed, then we go for model evaluation. Okay, now why it is important? We have designed the model. Okay, we should roll it out to the market, people should use it, or maybe we should start applying it in real life. But we can't do that, because artificial intelligence is the most powerful technology that has been designed by human till date. This is the only technology which has the capacity in the future to actually surpass the human capabilities. And we have already discussed this thing in the previous session, if you have attended the previous session, right? So when we discussed about artificial general intelligence, which is going to have the similar capacity or similar cognitive behavior like human, it's going to be a challenging thing for us to co-live with such a technology which has the same capacity like us. Because you are handling a computer, you're handling a smartphone, or maybe a smartwatch. Okay, maybe you're handling a robot. You know that there are certain limitations in that robot. Okay, the cognitive skills that you show, the humors that you crack, the emotions that you actually show, all these things are actually beyond the imagination, or beyond the capture of those technology. But at the same time, when you realize that we are developing this technology to such an extent that after a few days, this technology will also be able to laugh at your joke, or maybe start feeling angry at your jokes, or maybe start liking you or disliking you. So this is something very scary for us. So it's very important for all of us to evaluate the AI model. Okay, and not only that, we should also make sure that the expected output has been delivered by the artificial intelligence. Okay, so there are a lot of things that we need to think when it goes for AI model design or AI project cycle. So model evaluation is very, very important, because after the evaluation, then you decide whether this model is going to fit the human society or not? Is this going to actually deliver the data or the output that you have expected? So model evaluation basically is kind of you are assessing whenever you teach a child, teach a child for whole year, and you start, taking tests for the child, and you just, see how much the child is performing. Okay, that assessment is kind of, you can say, it's a result of your teaching, of your training. Similar thing happens with us. The assessment results will be the results of the data that we have provided to the AI model. Okay, and once the assessment and the assessment performance is actually accessed by the humans, we can figure out how this AI model is going to perform in real life and how actually it's going to ethically fit the society, right? So after that we go for deployment, right? So in deployment, basically the entire process ends in deployment, because deployment is basically we are rolling this AI model for users to use it, right? But yes, at the same time, if you can see here, inside deployment we have two things to be taken care of. One is integration and one is the monitoring. Okay, so integration is basically like you are going to integrate a lot of different models inside it, sub models. Maybe you're going to integrate a lot of data sets and a lot of algorithms and policies. Then you also need to keep monitoring the things, that because you need to find out how this artificial intelligence is actually behaving or how it's reacting to the real world scenarios. That monitoring is very, very important. Okay, now when you deploy an artificial intelligence model, post deployment, we might face lot of ethics and compliance issues. There will be ethical issues, there will be compliance issues. Okay, so until and unless we figure out those things, we cannot say an artificial intelligence model is completely done or the project cycle is over. A project cycle basically continues post deployment as well. So when we deploy the artificial intelligence model, we need to check its ethical behavior and compliance characteristics. Okay, so if I just talk about the example, the widely used artificial intelligence platform that you all have used, like ChatGPT, everybody used it. Okay, Google Gemini, which was known as Google Bard before. All these AI models were deployed many years back, but they were tested under a lot of ethical compliances, just to find out how ethically these artificial intelligence platforms are behaving. Because I told you that if this futuristic technology, if this very powerful technology is not ethically neutral, and if they are not very much ethically correct, then it will be difficult for the entire human race to survive among this ever-changing technology landscape. So that is something that we need to always take care of. So this basically, I'll just quickly recap through this. So initially we start with the problem definition, then we go for the data collection related to that problem, then we go for the data preparation. Basically we are going to get into the data science to train the model. Then we do for EDA, where we try to analyze the data that we have collected according to that problem. Then we deploy the data. We actually train the model on those data. We give the data to the AI model. Then we go for the model evaluation, when the model is actually tested under circumstances where the model has to give the output, and we find out whether this model is working perfectly or not. Then we go for deployment. So deployment is basically kind of live testing. It goes out for the users to use in real life scenarios. And then we go for ethics and compliance test, where we try to find out how much ethical behavior this AI is showing and how much compliance characteristics it's following. So these are the most important parts in any AI project cycle. Even if it's a very basic artificial intelligence you're developing, or if it's a very complex AI model that you're designing, the complete project cycle has to include all these things. Okay, now if we go a little deeper into this, how it actually works. Okay, so I would like to talk about the AI model evaluation here, right? So AI model evaluation is done to make sure of a lot of different things. Okay, so the first one is we should figure out whether this artificial intelligence is efficient or not. Okay, the first thing should be whether it's giving me the output that I am actually expecting or not, right? I'm designing an AI model to predict the weather. I want to know what's going to be the temperature tomorrow. I want to know, should I really take an umbrella going out tomorrow through from the AI? So is it really able to do that, right? So in that case, we need to evaluate it and we need to actually find out. So to make sure of all these parameters, whether the artificial intelligence is able to meet my expectation, or is it able to give the desired output, whether it's efficient or is it reliable, okay, can you really actually count upon that artificial intelligence model? There might be some issues with the data because of which the AI is not giving you proper output, and at some day, at some point of time, you are getting some output which is actually putting you in some danger or maybe some problem. Okay, so that might be also possible. So is it reliable? That is also something that we need to check. Okay, then we also need to think about its ethical consideration. Is it safe? So when we do the evaluation, all these things actually come to the come clear as a transparent things, like you get the proper idea whether this artificial intelligence is meeting your expectation, whether it's reliable, whether it's ethically correct, or is it safe for humans to use, right? So that is something that we need to do through the AI model evaluation. All right. So if I talk about the parameters, what are the things that we actually discuss here? There are a lot of parameters that we discuss for the AI model evaluation, right? We look for performance matrices. So performance metrics is very important because we designed this technology to actually do a lot of things in a real life. We use artificial intelligence models to decrease manpower. We use AI models to increase productivity. We use AI models to decode complex algorithms, or maybe complex thoughts that we find very difficult for a human brain to decode, right? So that's why performance is very, very important. So we try to figure out the performance metrics. Then robustness and reliability. Is it really robust or is it reliable? Fairness and bias. So that is something very, very sensitive and important topic in the AI evaluation. The artificial intelligence model is supposed to be very, very unbiased. It should not be biased to any community, any person, any country, or any kind of organization. It should be completely unbiased and neutral. Okay, explainability and interpretability. Is it really having that perfect explainability? We call artificial intelligence the a technology which has the capacity to replace humans. So in that context, is it really having the explainability techniques or explainability skills like humans, or is it really able to interpret what we do actually, right? Then the most important thing is safety and ethical considerations. If we are designing some powerful technology, it should be safe for everyone to use. It should not be replacing the humans in the future. It should not be a danger technology for the people in the future, right? Usability and user experience. That is also a very important parameter over here, because if you are designing a product, the user experience should be brilliant, right? The reason why ChatGPT has got more than million users within a few days is because of its user experience. It was very simple. The user interface was brilliant, simple, straightforward, and the you can say the speed of execution of the data in ChatGPT was also very, very fast. Okay, so that is something that has made the AI grow very fast. People started liking it, and it was the most you can say efficient artificial intelligence model at that time, right? The last thing is scalability and efficiency. Okay, yeah, already I have spoken about efficiency. The AI model has to be efficient, and scalability. Now see, into 2022, the artificial intelligence model, or maybe in 2021 or 2020, a lot of AI models were designed and they were very basic. Okay, even if you talk about the examples of Google Gemini or Google Microsoft Copilot, these were also there. They were with some different names. Like when we used to have Google Bard, which has been renamed as Google Gemini. So initially these AI models, even if you talk about ChatGPT, okay, initially they were designed only as a text model, which can generate only textual data, trained on a certain amount of data. But now you can see a ChatGPT can do almost every single thing. Okay, it can even talk to you like a human. It can even change its voice in multiple different accent. and even different genders it can pick up, right? It can even read your handwriting. It can read your handwriting, no matter which country you're from, no matter which which style you're following. So how it can do that? It can generate images that has no existence in this universe. Not only that, it is also having the capacity to generate videos which does not exist or which is not possible. So this is what we call scalability. An artificial intelligence model should not be restricted to only one single thing which was designed at the beginning. It should be having that scalability, right? So all these parameters are taken care of during an evaluation process. But what we get, let's say for example, we have evaluated an AI model. But what do we get in that case? What are the results? Okay, so let me show you the first thing that we get. There's something called underfit model. So every artificial intelligence model that we evaluate will fall under a certain category, right? So the first category is underfit model. So when we say underfit model, so from its name only you can figure out that it's an AI model which is underfit, like the way we call underrated, right? So it's not perfectly fit. It's not feeding the requirement or expectation of the user. So when we talk about an underfit model, basically it is not able to capture or recognize the data pattern. Okay, so I'll again go back to the example where I was discussing about designing an artificial intelligence model which can predict the weather tomorrow, which can predict the weather next week, which can tell me there's going to be an earthquake or tsunami. So in that case, you have already given the data to the AI model. For last 10 years data you have uploaded, you have given to the machine learning model. And let's say for example, you're putting, you're making a graph and you're designing some data points. Okay, in x-axis you're putting suppose the humidity, and y-axis you're putting the rainfall chances. Okay, it's as simple as a simple maths I'm talking about. Okay, now you put the values, it will put some kind of pattern, right? Now you can see in this picture what's happening in the picture. In this picture you can see the data pattern is following in a curve. Okay, it's going down here, but the AI model is predicting it in a straight line, as you can see. So it's actually has failed to capture the data pattern, right? So data pattern is something that AI model needs to figure out. It needs to learn how the complete data is forming a pattern, how in this last 10 years the data has changed. Here you can see the data pattern is going in a different direction, and the AI model, which is basically is shown through the dotted straight line, that is the capture that has been captured by the AI model. So that means you can figure out the AI model is capturing in a straight line, and the original data are actually following a curve structure here. The pattern is different. So that's why we call it an underfit AI model. So an underfit AI model is not a very good AI to use. It is a very poor artificial intelligence which is going to give you unsatisfied and incomplete output, right? Because it cannot find out the underlying data points in the complete data set. Okay, basically you can say it's an prediction with error, which is not going to give you the thing that you're expecting. Okay, so the next category of AI, that means when you evaluate your answer, your AI might fall in this category. Okay, or it might also fall in this category, which we call perfect fit AI model. So here you can see, now you can compare. This is the first one, this is the second one, right? First one, second one. So in the second one you can see there's optimal capture of data. So I'm using the same data here, same graph, same suppose humidity and rainfall graphs I'm putting here. Okay, and here my AI model has captured the complete pattern of data the way it is in real life. That means it accurately captures every single data point and it does not miss anything. So here the most important part of the AI model evaluation is the AI model should follow the pattern. The pattern should be followed. If it follows the pattern, then only it can predict the future. Like if it knows that if this is the humidity percentage, this is a chance of raining. If this is the wind speed, this is the chance of raining. So that means it has found out in last 10 years humidity has impacted the rainfall in this way, and wind speed has impacted the rainfall in this way. It's a kind of data brainstorming, and the AI finds out the pattern in it. So the AI model has now captured the exact format, exact pattern of the data. Okay, that's why we call it a perfect AI model or perfect fit AI model. We can also call it an optimal AI model, which captures the every pattern of the data properly. Okay, and it is ready to predict the future. Okay, what about the third category? So there might be another result. So first one was underfit, which is not a fit AI model. Second one is a perfect fit, which is a perfectly fitting. That means it's trying to figure out every pattern of the data, how it's falling. There is a third category as well, which we call overfit model. Overfit, right? So what is an overfit AI model? An overfit AI model does not go for the data pattern. It goes for actually every instance of data, and that is very, very it's messy. It's going to create certain output which you have never expected from the AI. Okay, we see the AI model has got into every single data instances which is not required. We don't want you to go through each and every data instances. I don't want you to follow what happened today morning and today afternoon, what happened today evening and tomorrow morning. No, don't go like that. You just tell me how today's humidity was impacted by the rainfall, how tomorrow's rainfall will be impacted by today's humidity. That's kind of a pattern I want to see. That's it, nothing else, right? So I don't want every instant value, every instance data. No, that is something that I don't want you to recognize. So if the AI model is recognizing or capturing every single point, every single data, that is called overfit model. And the most the biggest disadvantage of an overfit AI model is the AI model goes for over capturing the data. So in that case, the AI model does not find any pattern. Let me come back to the previous one. Here, if I ask you, where do you think will be the next movement of this graph? You have some prediction. If I hold my data right over here in the middle where the peak is there, if I erase it from here, you can find out that this will go down, right? But if I come back to this, can you tell me the next move? Where will this graph move in the next instance? Can you tell me? No, there is no way I can predict the next move, because it is not following any pattern. It is getting into each and every instance of that data, and that's why it's creating a completely confusing structure where the data is not following any pattern, and the AI model cannot predict the exact output that is going to be the unexpected output, right? So, and this is what we call a noise. In artificial intelligence model, there is something called noise. So noise means it will capture the things which are not required, which are not the main element of the data structure, data set. Okay, so that means we do not need the every instant changes of the data. I want the overall pattern changes of the data. So we don't want a noise, we want a complete pattern which will help me to get a generalized output in the future. Also it will help me in predicting the future, and also it will help me to understand how this data and this overall data set can follow in the future, like what will be the future movement, right? So that's what we call a overfit AI model. Now, overfit AI models are something that can be rectified by developing a more efficient data set plus updating the algorithm. So if your AI model is it's an overfit AI model, go back to the data set, go back to your algorithm, redesign them, again you deploy them, again implement them, it will rectify itself over time, right? So that's something about the AI evaluation, right? So now I'll be discussing something very interesting for everyone. So here you can just have a quick comparison between three things: underfit, optimal, and overfit AI models. Okay, so there you can see, like here you can see two in all the graphs. You can see I have put two variables. One is called predictor variable. Second one is called outcome variable. Okay, so let me quickly tell you about this predictor and outcome variable. What is a predictor variable? What is an outcome variable? So let's say, for example, I am trying to predict the rainfall using the humidity value. So that means if you tell me the humidity, I can tell you what is the rainfall chances. Let's say, for example, I'm an artificial intelligence. You give me the humidity, I can tell you the rainfall chances. How? So the humidity value that you give me, that is the predictor variable, which will help me to predict, right? And rainfall chances, that is the outcome variable. Okay, so that's how actually it's differentiated. The variable which we try to predict in the future, that is called a outcome variable or output variable, and the variable which is used to predict the output is called a predictor variable. Okay, so the next thing is something very, very important that we have already discussed in the previous session. In the previous session, if you remember, I discussed about machine learning model. Okay, a machine learning model is something that helps us, or that helps us creating an artificial intelligence, or a machine learning model is actually the backbone of artificial intelligence. Okay, so when we go deeper into machine learning model, we get something called a deep learning. Okay, deep learning. So here we'll be discussing about two different things. One is called artificial neural networks and deep learning. Okay, so what is an artificial neural network? So if I say from this word neural, you can understand what neural actually connects to. Neurals are basically connected to the things that we call neurons, right? So how our brain actually processes data, how our brain takes decision, it's only because of the neurons, right? So a neural network can also be formed artificially. So inside our body we have the neural network, functioning 24/7, which is helping us in taking decisions, which is helping us in decode a lot of complex algorithm, talking to people, finding out solutions for problems, or also it might be also surviving in this world. So that's how my natural neural networks are working. We can also create artificial neural networks. Actually, every artificial intelligence model has an artificial neural network working deep beneath the machine learning model. Okay, so like we have neurons in a brain, we have neurons, right? So we know that if you suppose if you want to take some decision, if you are you get hurt, let's say for example you get hurt in your hand, and that signal goes to your brain, right? The brain processes that you got hurt in your elbow and you need to take some action. So you need to just you cover your elbow, or maybe you just put your hand in that, or maybe you try to somehow pacify the pain. So that takes very less amount of time, right? It even does not take 1 second, not even a millisecond, to reach out to your brain. So that is only because of the neurons. So that is the speed of electricity, how it flows inside your brain. So that means some informations are carried to the brain at a very electrifying speed, and the brain comes to know what's happening in the surrounding, and the brain can take the decision. Same thing happens in an artificial intelligence model also. So artificial neural networks, basically it's a model, it's an artificial model which is inspired by human brains only. Okay, and it also consists of neurons. These neurons in artificial neural networks are called nodes. Okay, so these nodes are these are nothing but computer science program. These are all computer program. These are a part of the machine learning model, and a neural network basically helps the artificial intelligence model to assess and experiment on the data that the artificial intelligence model learns or gets. The neural network actually helps the AI model to get complete training on the data, how to recognize the data, how this data is changing, what are the patterns in the data, and what are the deep patterns which we generally can't figure out. If I give you 1000 numbers, if I give you 1000 numbers in a sequence, okay, you might not be able to find out the pattern very quickly, right? So but if you spend some time, if you spend 1 week, 2 weeks, 3 weeks, maybe you can find out some pattern in 1000 numbers. Okay, similar thing can happen with an artificial intelligence model too. You give a huge amount of data, the artificial neural network will classify the data, it will try to find out the pattern, it will find the basic deep learning concept. That's what we actually call deep learning. So a neural network helps any machine learning model to go for deep learning. Okay, so a deep learning is basically a machine learning model gets a capacity to explore more complex algorithm, more complex data concepts inside the machine learning model. That's what we call it, deep learning. So a neural network helps the artificial intelligence model to basically behave or act like a normal human brain, which learns from data that is acquired from the external world. Okay, so that's how we also get the deep learning concept. Okay, so in the previous slide I have already shown, this image was something that I have shown you in the previous session also, where you can see deep learning is a part of machine learning. Okay, it's a part of machine learning. So deep learning basically, it's a multi-layered concept. Okay, it's a multi-layered concept. So when the deep learning algorithm tries to find out the data, it does not only look at the surface pattern or maybe surface data, it tries to go beyond that. Okay, so that means like we humans try to figure out even the deeper concepts hidden in any kind of data. So when I'm saying data, you don't only think about numbers and text, it can be anything. It can be a bunch of birds flying in the sky, it can be an image that you're watching, you're looking at, or maybe it can be a movie that you're watching. It can be any kind of data, right? Or it can be a puzzle which you find on a paper, right? Or it can be a video game. So all this data we can figure out, we can decode all this data using our own natural neural networks. So similarly, deep learning is also using a neural network to decode and find out the hidden patterns and the deep concepts in the data. Okay, so when we talk about deep learning, that is basically a kind of unsupervised learning. So if you remember in the previous session, I spoke about supervised, unsupervised and reinforcement learning. So deep learning is actually unsupervised learning, where we don't supervise the model. Okay, it tries to figure out the things on its own. Okay, so for example, we can talk about natural language processing, we can talk about computer vision. These are the technologies that are actually built on the skeleton of deep learning, right? So next thing we'll be discussing about NLP, natural language processing. So NLP is something that we all are actually using. Okay, many of you have experienced NLP and you are using it on a daily basis. You all are using it, knowingly or unknowingly you're using it. Okay, so the best example of NLP are Siri. Okay, those who are Apple users here, they must be using Siri. Okay, Google Assistants, right? Alexa. So these are the examples where you talk to an artificial intelligence and the artificial intelligence replies to you and it executes certain thing which you are expecting it, right? So a natural language processing is the process, it's a capacity of any artificial intelligence model because of which the AI model can talk to you like a human. It can process all the natural language that you speak, right? So in natural language processing, what happens whenever you speak something, the voice that you actually utter, that words that you speak, those are converted into text. So basically it happens in two different ways, STT then TTS, which we call speech to text then text to speech. So whenever you say something, that is converted into text and this text processing happens. Okay, so the entire text is taken through a certain stages like tokenization, text removal, stemming, lemmatization. So these are the process where the AI model removes the unwanted parts of the text which has been converted from your voice and it tries to process that Okay, it also tries to find out the sentiments in the text, and then it tries to find out the answer for you, and whatever the answer it finds for you, it will convert the same answer into a voice and it will transfer it to you. And this is how you talk to Siri or Alexa. As simple as that. Okay, there are a lot of sub process and subsets involved here. Okay, that's why I'm describing it very, you can say in a simple manner. And when we talk about NLP also gives you a lot of different things, right? An artificial intelligence model can actually figure out what you are trying to say, because your words might be same but your sentiments might be different. So the modern artificial intelligence model also have the sentiment analysis. They can actually do the sentiment analysis. You might be saying the same word, same sentence, but if you change your sentiment, the AI can recognize it. Okay, they have the capacity to also do summarization. Okay, so that means if you have spoken something in a very messed up manner, you have not given a complete organized paragraph, the AI will do the same thing on its own. It will do the same thing on its own. You don't have to repeat it. If you're repeating certain words multiple times which is not supposed to be repeated, it will rectify your sentence on its own. So all these features are there, right? That is what makes NLP a very evolving technology in the present scenario. And now you can see that ChatGPT, Gemini, Google Gemini, Copilot, Grok, even Meta AI, all these artificial intelligence models are coming with NLP, and you can actually talk to them like a human. Okay, so the next thing I'll be discussing about is the computer vision. So computer vision and NLP, these all are based on the deep learning concepts or reinforcement learning concepts, where the machine learning model learns on a lot of data. So computer vision is also a very widely used technology, which is a domain of artificial intelligence nowadays. Okay, for example, when you see a traffic camera which can detect whether you are wearing a seatbelt or helmet or not. Okay, you find facial recognition model. Every smartphone nowadays is actually using the facial recognition model. We can use Google Lens, right? A Google Lens basically helps us in finding any object details using a camera, right? So computer vision is something that gives a computer or artificial intelligence to see the world the way we see, right? That means how your friends or your family members can see you, what you're doing, what things you're expressing through your physical movements or maybe your facial expressions. The AI models can also figure out the same thing using this computer vision technology. So computer vision is also a very evolving technology in the field of artificial intelligence, which is used extensively in all the technology gadgets nowadays. In fact, it's a product that is used in all the public places, airports, railway stations, markets, and shopping malls. Okay, just to have a safer world. So this is how it actually works, right? So computer vision is nothing but a vision that we give to a computer. So in our case, the brain is the computer, and in case of a computer vision AI model, the camera works as an eye, and there's a computer which is running the AI model, which can figure out the object which is coming in front of it. Okay, so this is just a brief idea about the computer vision. Now the next thing I'll be talking about something which is related to generative AI. Now generative AI is something that we have already discussed in the previous session. All right, so generative AI is something that has the capacity to generate data. Okay, now when you say data, it can generate textual data, image data, video data, or also it can also make a lot of different kind of data like audio files, like code files, right, like 3D models. So when we talk about generative AI, there are certain things that play a very important role in every generative AI. So these generative AI platforms are called language models, right? Already we have spoken about it. So language models actually work on certain things, right? So this type of generative artificial intelligence can be categorized in multiple types. The first one is GANs. GANs stand for Generative Adversarial Networks. Okay. Second one is VAE, which we call Variational Autoencoders, and the third one is RNN. RNN basically stands for Recurrent Neural Networks. So let me start with the first one, GANs. So what is a GAN? GAN is basically, it's a combination of two things. See, let's say for example, you are trying to create an image of Taj Mahal, right? Through a GAN AI. So GAN is basically an architecture which is which is something that we don't see as an user. Okay, but inside the generative adversarial network, so you can see adversarial, it means that there will be two different agents working inside the artificial intelligence. One will be generating the output, and the second one is called a discriminator. Okay, so now what happens is the generator tries to generate a fake data. Obviously it's a fake data. Okay, it's not a real image of Taj Mahal you are going to create. It's a fake, image. Now it will send the data to the discriminator. Now the discriminator's job will be to find out whether it's a real Taj Mahal or it's a fake Taj Mahal. Okay, so the discriminator will always try to find out the fake data, whether it's fake or whether it's real. Okay, even if it if it is having 1% of doubt on that image, it will categorize that as a fake. It will send back to the generator again. The generator will again try to modify the picture and again send it to the discriminator. So within microseconds, within milliseconds, this process happens in thousands of loops, millions of loops. Generator, discriminator. So this is kind of a competition. I'm creating something and somebody is finding a flaw on my picture. So that means my quality will improve, right? So this is how a generator ends up creating something which at the end the discriminator thinks is a real object, and it categorizes it as a real and it gives the output. This is how GANs actually work. Okay, the next one is VAE, which is called variational autoencoders. So VAEs are basically, see how these are all actually machine learning model training process. Okay, so variational autoencoders, this is also an unsupervised learning. So this is also an unsupervised learning where we don't supervise the machine learning model to learn about something. Okay, so variational autoencoders, what it does is we will use an encoding decoding process. So that means, let's say for example, I'm trying to teach my AI model on this certain picture. I'm trying to find out, teach that this is an art and this is a cat, right? So the cat image will be encoded, okay? And it will go through a certain hidden process, which is called a latent code, or it's also called a latent stage. So now what happens is the decoder does not come to know what actually it was encoded to, right? So what happens is the encoder converts that photo into something else, gives it to the decoder. Decoder tries to do a back propagation. This is called back propagation. That means it goes back and tries to find out what it was converted from. And the AI model now learns, it decodes and finds the real picture, right? So now this is actually called a VAE model, that's variational autoencoders model, where a machine learning model learns through encoding and decoding, which goes through a latent or hidden stage of learning. Okay, this like I use this picture to simplify this concept. All right, the third one is RNN, which is called recurrent neural network. Okay, so now already I have discussed about neural network. You have understood what neural network is, right? Now a recurrent, so recurrent, the word recurrent means repetitive, something which is happening again and again. So in this case what happens, if you can just figure out this picture, there's an input layer and there's an output layer and there's also a hidden layer. Okay, so let me tell you what happens actually in this case. If you also check the previous, the next picture here. So now what happens, the machine learning model, the neural network basically works on a repetitive process. So how it works, suppose there's a picture of a cat. There might be multiple features in this picture, multiple features. So what we will do in a recurrent neural network format, we will give to the model one feature at a time. So multiple features will be given in multiple different stages. So here you can see the next image, I have put one input layer, recurrence, hidden layer and output layer. So one feature I have given, which is given to the RNN, it gives an output. Now what happens, the output of this stage will be taken to the next stage. That means second feature which I'll be given, which I'll be giving to the model will be actually taking two different inputs. So the output of the previous feature and the input, which is the second different feature, because there are suppose feature 1, feature 2, feature 3. So in the second stage I'll be giving the feature 2 as an input, but the output of the feature 1 will also given as an input in that model. So now in the second stage the AI model gets two inputs. In the third stage it will also get the third feature as an input, also the output of the second stage. So like this it keeps on happening. That's why we call it a recurrent neural network. So in that case the AI model can actually give you the output which is almost 100% equivalent to a real object. So this RNN, VAE or maybe GAN, these are the techniques which are used in mostly generative artificial intelligence, where you are trying to generate an image, video or in textual content or any kind of graphics. Why it's important? Because we need to have perfect data which does not look fake. That's why this kind of process, this kind of techniques are used in generative artificial intelligence. So we're coming to the last topic of this session. Sorry, we're exceeding little more than the expected time because we started a little late because of some technical glitches. So this is the last topic we'll be covering, programming languages used in artificial intelligence. So Python. So let's not spend much time about discussing about different programming languages, but I want to say one thing over here is there are a lot of different programming platforms and languages that exist for artificial intelligence. Java, R, Haskell, Julia Computing, even Lisp. So Lisp is the actually oldest programming language, which was designed by John McCarthy, who is called the father of artificial intelligence, if you remember the previous session. So Python is actually taking the center stage here. The reason being, Python is the most efficient and most widely used programming language connected to artificial intelligence. Even if it's a beginner student or the person is an expert, the person can use Python programming for any kind of model design, artificial intelligence, UI design, or maybe even data science project. Everything can be done using Python. So that is why Python is also called the language of future. With the evolution of artificial intelligence, there will be a lot of programming languages which will not exist in the future. Okay, you can guess what are the programming languages I'm talking about. I won't take any name over here, but there will be some programming languages which will not exist in the future. But at the same time, Python is called the language of future. Why? Python has lot of features. It has lot of features, so it has endless number of libraries. Okay, here's a numbering mistakes, so please forgive me for that. So if we talk about libraries, as per the record of 2022, Python has 3,80,000 different libraries. Think about it. 3,80,000 libraries. It's not a small number, right? Then ease of learning. So artificial intelligence can be learned very easily using Python programming. Okay, and it also has a lot of versatility. As I've already told you, it can do all the type of projects like data science, deep learning, and machine learning model design using Python programming. Okay, and last one is industry demand. So present scenario, if you look at the career market or even the job market, artificial intelligence is one of the most you can say lucrative career options, and in this case Python is playing a very important role. Okay, every individual who is upskilling themselves in Python programming are ready to they're good to go for any kind of AI job or AI career option. So that's why Python is one of the most important programming languages that anyone should learn. Okay, here if I just show you one quick example here, if you can see. So just one second. Yeah, so I'll show you one example here. Okay, so this is a small very simple or small Python program which is using a dictionary. So those who are doing Python programming, they will know what is key value in this dictionary, right? So we have created a very small Python program here using a forever loop. Okay, we are using some conditional statements here using if else statement, and there is a dictionary that we have designed where we have put some questions and answer, right? Questions and answer. So these are basically the data which I'm considering as a data for the artificial intelligence model. So I've written this code in Google Colab. So if I run this program, I'll just quickly show you what type of things it can do. Okay, this is a basic Python program which is written in. So now you can see I have a space to type here, right? I have a space to type, and I can type some question here. Let's say, for example, if I type a question, what is your name, right? This is a question. I press the enter. Now you can see I'm a simple chatbot created to answer your question, right? So here actually you can see the AI model, this chatbot has already got the information. I mean, what to answer for this certain question, it already knows. If I ask here, what is robotics? Okay, I'm asking what is robotics, and you can see it's giving me an answer. Robotics is the branch of technology that involves the design, construction and operation of robots. So this is a very basic example of Python programming where you can use this code to just design a simple chatbot. Okay, not only that, there are examples of prediction of, so this is a program where we're using some library called NumPy, and we're using this simple program to predict the rainfall given with some humidity inputs, right? So this is the process of using Python programming, and over the time, if you learn the basic concepts of Python programming, you can actually figure out how it can be utilized for the bigger projects and bigger like achievements, right? But we should always remember one thing: Python is the most important programming language at this point of time if you are into the field of artificial intelligence and data science or machine learning. Okay, so with this I have come to the closure of the session. I hope you have learned something. I hope the session was beneficial for you, and we will be having multiple sessions in the future related to different technology domains. Okay, we'll be discussing about various things related to computer science, maybe cyber safety, or maybe coding in the future. So please don't forget to share this video with your friends and families or your colleagues, and this video will be available post live in the KIPS Facebook page timeline. Okay, so here on behalf of entire KIPS team, Mrinal Hira signing off. Thank you everyone. Thank you for joining. Have a great evening. Thank you. Thank you so much.